Hello, my people. Good evening, or good morning, or good afternoon, wherever you are and you find yourself watching this video. It's been a long time, and Happy New Year, everyone. I've not been on this channel for some time, and this year I promise to be more consistent, with my Kubernetes management and the tutorials you've been doing to fix some small issues that usually come up. And also this year I'll be trying to add DSA questions to what we do. So that's what we'll be doing today. Yeah. This morning I was trying out a question that was very interesting to me. So it's about palindromes and substrings. If you don't know palindromes, let me introduce you to palindromes. So, a palindrome is a word that mirrors itself. Okay, why is this thing behaving like that? So, let's take the word what? Abba. Abba is the name of a lady in Ghana. So, Abba. When you place it in front of a mirror, when you place anything in front of the mirror, the left becomes the right becomes the left. Okay. So let's start from the right to the left and spell out whatever is on our screen. So we have A, we have B, we have A. Forget about the capital letters. We still have Abba. Okay. Another name like Amma. Amma is a name for a lady who was born on Saturday. So we have A, we have M, we have A, AMA. So it mirrors itself. That is a palindrome. Good. A substring, I believe all of you are aware what a substring is. So a substring is a subword of a word. All right. So the reason why this problem is very interesting is it's kind of combining the two. So let's see. Given a string S, huh? Given a string S, I was already solving it. So given a string S, okay, return the longest palindromic substring in S. So there is a substring in S which is longer than all the other substrings which are also palindromes, and you have to return that substring. So this is what it is trying to say. So let me use the word BABD as an example. Okay. So for BABD, okay, we have a lot of substrings of BABD. We have B as a substring. We have BA as a substring. We have BAB as a substring. We have BAD as a substring. We have A as a substring. We have AB as a substring. We have ABA as a substring, and so on and so forth. Now, when you look through this substring, some of them are palindromes. For example, BAB is a palindrome. When you place a mirror in front of it and you spell it backwards, you get BAB. It's the same word, right? ABA is a substring. When you place a mirror in front of it, you get ABA. It's still the same word. So we are trying to retain the longest of all these words. So in our iteration, you see that we will get BAB first. Then we see that ABA is also a palindrome, but it's not longer than BAB. So we can still retain BAB and so on and so forth. Then our final answer will probably retain BAB. So that's the problem we are going to try and solve. Okay. How are we going to do it? In order to do this, so let me go back to the other screen. You see how we did it? We look for every character. For B, we loop through to get all the possible substrings we can make with B. Then for A, which is the next character, we are going to loop through to get all the possible substrings we can make with A. Then we go to the next character. Then we loop through to see the substrings we can make with B, and so on and so forth. It's like I've said and so on and so forth like three times. So let me put dot 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 so that it will encapsulate all of that. Yeah, but that's pretty much what I mean. So let's try something. Okay, let's try something. All right. So for I in a range of the length of s, okay, for I in a range of the length of s, what are we going to do? For so that will look through the word s, but we haven't gotten the words we are interested in. So we have to get words for each character. So we loop again. So for J in, now this is where it gets interesting, because you see that, let me show you. You see that for when we are doing B, right? We have B, we have BA, we have BAB, and so on. So the window that comes to add up to make the substring is always on the right side of the character we are dealing with. Okay, I think this is frozen. It's always on the right side of the character we are dealing with. So let's implement something like that. So for j in a range of what, I plus 1, okay, then the length of s plus 1. There is a reason for this. The reason for this is that when we don't add 1 to the range of s, most at times the last letter in the list, all right, which is the D over here in this case, will not be included. So we see that when we print, we'll get B, BA, BAB, BABA, but the D will not be included. So we add the one to it so that we can include, like we can, it's like we are stepping out of the word so that we can include the last word. It's due to the way Python indexing works. When the word is two characters, the indexing for the first character is 0, the indexing for the second character is 1, but the length is 2, right? So we add 1 to the length so that we can index it right. Good. So we do this, and then let's print it. Let's print s, right, from I to j. Let's print s from I to j and see something. Okay, so you see we have B, we have B. It's a lot. We have BAB, Baba, Babad, and all that. So that's pretty much what we are dealing with. Okay. All right, cool. So we need a global identifier or a variable, a global identifier or variable to hold our longest substring. Currently, when at the time that we start the algorithm, we haven't identified any substring, any we haven't identified anything. So our longest is longest substring, right, will be nothing. Okay. And let me do this. If the length of s is 1, just return s. We don't want to waste our time. If the length of s is 1, it's that thing. Like if the s is just character b, then the longest substring is b. Okay. So we are not going to waste our time. Okay. But if that's not the case, then we do all this. So these are our substrings, all right? So substring is this. So longest palindrome substring is nothing. Substring is this. All right, cool. Now, if the substring, right, is the same as the substring, but reversed, right? If you reverse the substring and it is the same as itself, and the length of the substring, okay, that's pretty much what this thing is saying, right? A palindrome means the string is the same as the reverse of itself, right? And we are saying that it is the longest, so its length is longer, okay, than what the so far longest substring. Okay, if that is the case, can I move this around? All right, I can move this around. If that is the case, then the new longest substring is this. Now, when all is said and done, return our longest substring. So let me go through the code a little for you. So when we are initializing, our longest substring is nothing. All right, it's just an empty string because obviously we haven't iterated through the whole string. Now, if the length of the string is one, we return it. We don't want to waste our time. It doesn't really make a difference in the complexity, but you know. Now, for I in the range of the length of s, so we are going through the whole substring. We are going through the whole string, and we are trying to form substring for each character in the string. So we do this for j in the range of this, right? I plus one. So the letter next to it, all the way to the last letter, we iterate through them. Now, substring is the character that we are currently working on, and the character that the window, this is the window, all right, the sliding window, the character that the window is currently on. So this is the character that currently we are pivoting at, and this is the character that currently the window is on. You get it? Good. Now, when we get the substring using this indexing, if or slicing, Python people like to say slicing. If the substring, right, is the same as the reverse of itself, the mirror of itself, this is how they kind of handle reverse of list. In Python, you can handle a string as a list and do some operations with it. So if it's the same as the reverse of itself, it's a palindrome. That's our first condition. If its length is longer than the longest substring, the longest palindromic substring we have so far, right? If its length is longer than the longest palindromic substring we have so far, then the longest palindromic substring we have now is this guy. So let's run it and see. Let's go. Is it going to pass our test? There is and length of substring. So you see, there's a type error. It's not supported between instances of length. Okay, I get it. So we need to bring length here, right? Cool. So we are comparing the lengths, right? So let's run it again. So in the first test case, BAD, it's returned BAB. The expected was BAB. The second case, CBBD, there was the output was BB, the expected was B. In the third case to abracadabra, it was expecting raka. This is the actual spelling of abracadabra, not the thing I spelled. And it's returned raka. So this is how to use the concepts we have in lists and strings, list that applies to strings, slicing them, reversing them, and looping through them to kind of solve this issue of longest palindromic substring. All right. So I'm submitting the answer, it's judging the answer, and it was accepted. Um, Let me see. Oh, really? It only beat 6.86% of the answers. The runtime beat 6 points. I mean, it's not that much, but at least it solves the question. We can still improve it. Let me see. They have this thing where you can analyze the complexity, right? Or upgrade to analyze more. Okay, that money. Anyway, so that's it. I think we can improve this code to reduce the complexity. We are doing one looping here, we are doing another looping here. Already O of n of to n to the power two. Then over here too with the reversing that is happening here. I'm sure Python doesn't handle it straightforward. Probably an O of n or something. So maybe O to the n, O n to the power of three or something. So we can work on it to improve it. Let me see in the comment section if you worked on it and had some improvement in the complexity. Thank you very much and see you another time.